we started building out, we went kind of quick with it. And I thought that the first thing that we wrote in here were our degrees. So we start at 0. We start at 0. Here's 180. Well, if we go all the way around, we go to 360. Half of 360 is? What's half of 180? 90. If I add 90 and 180 together, I get? After that, we talked about the idea of where the radians come into play. Radians start at 0. 1 full revolution of a radian is how much? 2 pi. So this is 0 and 2 pi. Half of 2 pi is 1 pi. Half of a pi is, if I add a whole to a half, I get okay. After we did that, those 4 values right there are what you call your quadrantals. Quadrantals are the angle measures that land on the axes. A quadrantal is an angle measure that lands on the axis. Okay. What's half of 90? Okay. So our 45 was here. What's half of a half? So that was pi over 4. Okay. If I count by 45s, 0, 45, 90, 135, 180, 225, 270, 315, then 360. I just counted by 45 degrees going all the way around the circle. Okay. Now, if I use the idea that every fourth is a pi, every 45 degrees is a pi over 4, you start at 0, 1/4, 2/4, 3/4, 4/4, and so on. So you have 45 was pi over 4, 90 is 2 pi over 4, 135 would be 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and then 8 pi over 4. All we're doing is adding fractions. Okay? Not bad? Okay. Now, after we did that, we also talked about the relationship between 90 degrees and 30 degrees. 30 degrees is how much of 90 degrees? 1/3. Okay. So if we go to our 30 degree line, excuse me, here's our 30. And if I count by 30 degrees going all the way around, well, here's 30 degrees. What's this one? 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, and 330. Everybody okay with that? I just want to make sure I didn't go too fast on this. Okay. The way that at this point you guys should just sit there and go, huh, I bet you there's something to do with these 30, 60, 90s, and 45, 45, 90s are going to come back and play here. Probably. Just a smidge. Not much. Yeah, just, I would pay no attention. Yeah. Now, if 90 degrees is pi over 2, 30 degrees is 1/3 of that, what is 1/3 of a half? A sixth. So now at 30 degrees, every 30 degrees is a pi over 6. So when you have 90 degrees is pi over 2. 30 degrees is 1/3 of 90. Okay? So if I multiply 90 by 1/3, I get 30 degrees. So if I multiply pi over 2 by 1/3, I get pi over 6. Is that okay? So that means that for every 30 degrees that I go up and around, I'm adding 1/6 of the circle, which means I'm adding pi over 6. So that's where we get pi over 6. At 60 degrees, it's 2 pi over 6, but we write that as pi over 3. At 90, it would be 3 pi over 6. Then we get 4 pi over 6. 5 pi over 6. 6 pi over 6. 7 pi over 6. 8 pi over 6, which is the same thing as 4 pi over 3. 9 pi over 6, which is 3/2. 10 pi over 6, which is 5/3. And then after 10 pi over 6 comes 11 pi over 6. Because at 2 pi would be 12 pi over 6. What you're doing here is you're counting by the fractional amount every time. Okay? The other things that we did yesterday is that we talked about the quadrants. Remember what I meant by the quadrants? What values are positive, what values are negative? In the first quadrant, what's positive, what's negative? Everything is what? So in the first quadrant, they're both positive. Second quadrant, and third quadrant, and fourth quadrant, positive, negative. Remember, so it goes X, Y, so you guys remember on that one. Okay. Now it's where things can get interesting. So, if you have a theta value placed there, if I have a theta value placed there, what does that mean? Makes a 30, 60, 90 triangle, doesn't it? Not arc lengths, because what does that theta value equal? 30. E equals 30, okay, because that was the terminal side coming up. Now, when you have your, if you guys remember this, when you have 30, 60, 90 triangles, remember how you guys wrote that out before? X, x root 3, 2x. If I get rid of the x's, can I just do 1 root 3, 2? Okay. So opposite my theta value is 1. Adjacent is the root 3. And my radius, or my hypotenuse, is 2. Okay. Now that makes, if I look at that then, I have some sort of ordered pairs there, don't I, for the value where that's being placed. I moved over root 3 and I went up 1. Okay. Now, what's going to happen here is that when you move over, that's your adjacent, isn't it? Adjacent is your what? What trig function is your adjacent? Cosine. Your vertical is your sine. So what happens here is that you get ordered pairs. You'll have ordered pairs going around for your cosine and the sine value for every trig function. Because your cosine values are your horizontal, they're your x values. Your sine values are your verticals, your y values. So as you go through, if you remember, what's the cosine of 30 degrees? It's something which is adjacent over hypotenuse. Well, adjacent's √3, hypotenuse is 2. What's the sine at 30? 1/2. Another nice way to remember this, what comes first in the alphabet? Cosine or sine? Cosine. What comes first in the alphabet, x or y? X. Kind of convenient how it goes that way. Now, this is also why I kind of wish that on calculators, they would go cosine, sine, tangent. They don't. They go sine, cosine, tangent. So we tell that sine comes first. But in all honesty, cosine comes first because they were in pairs. All right. Now, if I do that again with the 45, if I look at my 45, 90, what were the ratios of the sides? What were the ratios of the sides for 45, 90? Yep. 1, 1, and √2. Good. So what's the cosine of 45? 1 over √2, right? Well, it's √2 over 2. Very good. So your cosine and sine value are √2 over 2. They're both the same. That's convenient because we'll get to that. I won't tell you yet. And then if I look at 60, if I go to my 60-degree angle, what's my cosine of 60? 1/2, and my sine is √3 over 2. Now, here's where it gets really, really easy. Because, well, honestly, if you really go into it, the only thing that was new that I just talked about with you guys is that cosine is your horizontal, sine is your vertical. That's really the only thing new here. You guys have done special right triangles. We did a little bit of it here. You did a lot of it in geometry. The idea of placing those things, that's not anything crazy. The only thing that I just mentioned to you guys that was new was the fact that cosine comes first in the alphabet. Now watch what happens. Do you guys agree that this theta value here is 30 degrees? And then this theta here is also 30 degrees. Is it 150 degrees, 30 degrees up from the 0 line to 180? So what happens here is that these two guys, those two guys are horizontal from one another, aren't they? When you're horizontal from one another, what value do you share? Your x value or your y value? Your y value. Your y values are the same. So what's the y value of 30 degrees? 1/2. So what's going to be the y value at 150? 1/2. Now, it's going to be negative because what becomes negative in the second quadrant? The x value. So the x value becomes negative. What's negative for x? It's cosine in the second quadrant. So you get negative √3. You get negative √3 over 2. Same deal happens with the 45. When I take the 45 and I move it to the second quadrant, I'm moving it horizontally. If I move it horizontally, what value changes? The y value again. I'm sorry, the y value stays the same, the x value becomes negative. So at here, it's negative root 2 over 2, root 2 over 2. What happens at 2 pi over 3? What's the ordered pair there? Negative half and root 3 over 2. All I did was I took everything from the first quadrant and just reflected it to the second quadrant. And all I did, in order to do that, the only thing that changes is the x value. X value in trig is your cosine. So far, so good? What values will change when I take that second quadrant and fold it to the third quadrant? The y becomes negative, and how about the x values? They're also negative. Very good. As you reflect moving downward, this 150 to here, it's also a 30 degrees off the x-axis. So it's the same triangle that's just been reflected downward. So the ordered pairs become the same as here, but they're both negative. Negative root 3 over 2, negative 1/2. What do you think the next one's going to be? Yeah, negative root 2 over 2, negative root 2 over 2. And then the next ones will be negative 1/2, and then negative root 3 over 2. Now, right about now is usually when students start going, do I have to memorize this? Hell no. Seriously. And that's this is a great tool to have, especially as we start going with trying to figure out trig values. But in all honesty, if you understand where things are positive and negative, if you understand how to find how far something is off the x-axis, everything else falls into play. It's a matter of, how we were spinning it to win it. Remember, I'm going to go around 3, we went 5 pi, and you want to go over here. By understanding that as you spin around 5 times, or 5 pi, you go 1, 2, 3, 4, 5, you drop down a third. At that pi over 3, you were down here at 240 degrees, which was 4 pi over 3. So you understood where all that stuff was coming out of. Okay? And then you can find your sines and cosines, and then as we get there, tangents as well. Okay? And then the last ones on the other side, could you figure out how to fill those in without so much of a hassle? All right, so let's see here. We have root 3 over 2, negative 1/2, root 2 over 2, negative root 2 over 2, and then 1/2 and negative root 3 over 2. If I'm not mistaken. Real quick, before we get too far away from this, how do you find tangent? It's opposite over adjacent. So if it's opposite over adjacent, isn't trig function, isn't that sine over cosine? Isn't because remember your opposite is when you're looking at it, if you're in place at theta, your opposite is your vertical, your adjacent is your horizontal. No matter where you're placed, as you sit here, if I'm looking here, that's my opposite. My opposite went vertical. My vertical is always a sine value. We'll get there. We haven't gotten tangent yet. I just wanted to make sure you guys see how you build and where this goes for. What I wanted you guys to do today is I'm going to kind of do that, and I wanted to do a couple extras of the kind of the stuff we did last night. And it looks like there's a lot, but it's spaced out. I'm not going to have to do all of it. Yeah, we did a pretty good chunk of these. Sorry. Pick a number, 1 through 10. 1. There's 3, so do the odds. Well, it's better than doing all of them.
No, that's not what I meant. If it was odd or even, you already had a number.
Yeah, so like this, right here. Let's do the odds. I think it's fair. They're good. They're just good. They're exactly the same style problems that we did last night. Super easy to work with. That's about what you did yesterday. Not wrong. Okay. What'll happen a lot with these things is we get, especially starting tomorrow when we start talking more about the unit circle. We did, if you notice, we did not put any ordered pairs on the 09270s. That's a whole different ballgame, but we'll worry about that tomorrow. And we'll also talk about the trig functions placed on the unit circle tomorrow as well. Okay? Yay, trig is my friend. Odds. Trig. I love trig. I'll probably lose it.